Hello and welcome to my new video. This time, Charlotte's delightful AI voice will take you through my attempts to get large language models, LLMs, up and running in ComfyUI. After my last video on Mimic PC, I felt somewhat discouraged by the strong correlation between high image quality and the hardware used, just as strong as the price tag of such hardware, particularly GPUs. My compromise was to invest in 64 GB of RAM, allowing me to finally experiment with these LLMs. Over the past 3/4 of a year, I've generated over 23,000 images, and my main takeaway is this. My natural language processing abilities are fundamentally different from those of the text encoder models we use, both generally and within ComfyUI, to generate images from text. Human speech and comprehension are not driven by stochastic and probabilistic processes like those found in neural networks. When it comes to prompting, it often feels like we're simply getting lucky. Our words might align with the right classes in the model's training data, and the resulting image turns out exactly as we imagined, or even better. Other times, no matter how much we tweak our wording or adjust weights, the model just doesn't respond as expected. And because image-generating models lack a text output function, we can't simply ask them how best to trigger concepts like surrealism within their weight structures. But this is where large language models come in handy. They also use the clip text encoder model, just as SDXL models and others do. The only difference being that SDXL models don't utilize their text output capabilities. This led me to an intriguing thought. If LLM-based prompt enhancement truly is as superior as, for instance, the currently hyped DeepSeek Janus claims, then perhaps different AI models understand each other better than they understand us. AIs of a feather flock together. This is likely due to their shared architectural principles. What interests us most are LLMs with visual understanding, meaning they can analyze images and generate text descriptions that we can then use as prompts. And from my experience, this approach works particularly well with SDXL models. Let's take a look in ComfyUI. Since I prefer to use open source models, we need an easy and efficient way to download and run them. Ollama.com is a great solution for this. You just need to download and install it. And once started, it runs quietly in the background. Using the command prompt, we can download our chosen models with Ollama run. Once that's done, we'll get a success message and can already start asking the model questions to check that it's functioning properly. For ComfyUI, we primarily need two types of LLMs: vision models for image analysis, text-based models for refining and optimizing prompts. Mini CPM by OpenAI has proven to be particularly useful for text-based tasks. However, the downside of running these models locally is their high resource consumption. To ensure they run smoothly, we should opt for smaller, quantized versions. These are significantly reduced in size while maintaining good performance. I did test some of the larger models with 70-90 billion parameters, but those require either better hardware or a lot of patience. However, models up to 34 billion parameters worked fine and were usable in ComfyUI. How the workflow functions in ComfyUI. 1. Load image node. This node allows us to input an image for analysis by an LLM. The image is processed, extracting relevant textual descriptions that will later help optimize our prompts. 2. Ollama Vision Node. This is where things get interesting. a Vision LLM analyzes the input image. The prompt used in this node instructs the model to describe the image using photographic concepts, such as depth of field composition, exposure time, focal length. This description serves as the foundation for our prompt refinement process. 3. Show text node. To verify the output of the Vision LLM, we use this node. It simply displays the raw text description generated by the model, providing insight into how the LLM interprets the image. 4. Ollama Generate Advanced node. This is where we refine the raw description into a structured and optimized prompt. The node performs the following functions: converts the description into a highly detailed and structured prompt, optimizes wording for SDXL models using the clip text encoder, limits the output to 256 tokens to ensure efficient processing. This ensures that the generated image aligns as closely as possible with our artistic vision. Key parameters in Ollama Generate Advanced. URL connects to the local Ollama server. Model selection defines the model used for prompt refinement. Creativity and randomness settings of the model. Top K, default, 40. Limits the selection to the most likely words. A high value increases variety, while a low value results in more conservative choices. Top P, default, 0.9. Selects words until a certain probability threshold is reached. Similar to Top K, but more adaptive. Temperature, default, 0.8. Higher values increase creativity and randomness, while lower values make the output more focused and predictable. Num predict, default, -1 equals unlimited, sets the maximum number of generated words. TFSZ, tail-free sampling, default, 1.0, filters out unlikely words for a more natural and coherent output. Higher values make the text more focused. Lower values allow more randomness. Keep alive. Prevents the model from shutting down when idle, keeping it ready for faster responses. Keep context. Keeps previous responses in memory for smoother multi-step refinements. Format, text or JSON. Defines how the output is structured, plain text for easy reading or JSON for structured data. This was just a brief introduction to using LLMs in ComfyUI. Of course, I also tested FLUX, and I discovered that its more complex architecture, which integrates not only CLIP and T5, but also image segmentation techniques, makes it harder for LLMs to generate suitable prompts. However, I've developed an approach to fine-tune LLMs for FLUX, allowing them to better align with its structure and directly activate the various classes and concepts stored in its weight matrix. The ultimate goal? To eliminate the randomness in FLUX prompting and make it adaptable to our individual creative needs, a sort of customized LLM FLUX workflow. But this is a highly complex and time-consuming endeavor. If you'd like to support the channel and my work, you can do so via Buy Me a Coffee. The link is in the description. And of course, I'd greatly appreciate a subscription and a like. Last but not least, have a nice day.